Hi everyone, welcome to today's virtual chapter performance meeting. We have a great presentation today. I will be your moderator, Leslie Weed, and here is information about the performance chapter information in case you need to reach out to us, provide questions, comments, or if you are interested in speaking, please reach out. For the webinar, you will have a little control screen. And if you have any issues, please let us know. I do want you to know that Con, our presenter today, is having a few problems with his microphone, so we're going to do our best. So please be aware it's not just you, but Con is going to try to make sure that he's audible for you. Our sponsor today is SolarWinds. We appreciate their sponsorship every year. This is fantastic. We will have a gift card going out today. And so thank you for joining. You might win that. So our presenter, Constantine, he's going to be talking about optimizing your data warehouse for OLAP processing. I look forward to hearing about this. So I'm going to go ahead and make him the presenter right now. And Constantine, you are ready to go.
All right. Hi, everyone. So as Leslie was saying, this is optimizing the data warehouse for OLAP processing. I'm apparently very lazy, so I did this presentation for 4 hours have passed, and I started to change the template. That's why you see the 24 hours have passed. So a little bit about myself. I run SQL Server architecture and business intelligence groups within a company called RDX, RDX is a really managed service provider, so we support a variety of clients, touching basically on any aspect of these platforms, from anything within SQL Server, Oracle, Mongo, Postgres, basically all the major players in the game currently. And so we do like remote database administration, development, design, troubleshooting, whatever we actually clients need us to do. So we do see almost everything there is to see in SQL Server at this point. And sometimes we see things we don't even want to see, like SQL Server 7. All right. So before we really get into this, there's a couple of things I wanted to kind of lay out. You guys should already know or have an understanding and diving into the optimization. You should have a cube. That's kind of a starting point. You want to optimize the process. And you should have a working knowledge of SQL on OLAP. You don't have to be an expert at it, but you kind of have to understand how things flow. Now, for this presentation, we're going to be primarily focusing on the actual data warehousing part, how to get data to the OLAP engine itself as fast as possible. So it's really like the data pool of the process. There's two phases where the processing part of it. The pool part of it. So why are we actually trying to do this? So everyone said the data now we have the cube. We started collecting all the data. 5 years goes by, and all of a sudden it takes forever. So our data set grows exponentially. The definition of data warehouse is historical data we have over days. And once we run out our window to actually get we have some choices to make. And a lot of times, we'll go weekly instead of daily, monthly or quarterly, which is sometimes is acceptable as a new business. But, I mean, ideally, we want to have a 19-month cycle that actually takes care of things for us. One of the options generally Windows is just add hardware resources. Well, sometimes that's not an option, or you're already kind of the top tier. You have a monster box, and there's really nothing that much better than what you already have. We actually have a client, one of our clients, who has that situation. And entire compelling sun dedicated to it, OLAP storage, have monster servers, 3 terabytes of RAM, um, dedicated OLAP, and we cannot process within 8 hours. So we have to do something for them to get the window.
Hey, Con, I'm sorry to interrupt.
Yeah.
It kind of keeps going out a little bit. I think maybe if you just talk slower, it might help.
Okay.
I'm not sure if it's the IP or what, but yeah.
All right. I'll do my best. Just keep me honest.
Okay, thanks.
Okay. So sometimes, as I was saying, adding resources is really not an option for us anymore. Um, and the other thing generally that we want to try to do is actually keep our changes we have to do to our data warehouse or hardware configuration or database engine to a minimum. Because we don't really necessarily know what else is going to affect. We might stream down the proof from the warehouse and the OLAP, so our net gain is actually different. And I usually ask if I do this interactively. But if you are processing kind of still, actually DBAs won't. Try to keep our production as happy as possible. All right, so that kind of leads us to our for today, and our objective is to minimize it down. Now, how we're actually we're going to talk about some best practices considerations. Those are not silver bullets and not um, the um, you will not always be able to actually implement them in your environment, but if you can, that's all generally a good idea. We're also going to talk about some enterprise features. Generally, if you get to certain sizes um, and we briefly forget if we have time left, we'll talk about incremental processing. All right, so let's actually get into some best practices. So there's not in any particular order, and there's definitely not all of them. The and the first one is using of circuit. Like any computer numbers, you can have numbers as your keys, it will perform. Now, to avoid with circuit keys is you don't want to start creating surrogate keys of surrogate keys of surrogate keys. So if you have multiple
Hi, Con.
yeah.
Yeah, I'm like not hearing you at all.
Wow, I don't. This keeps happening to me.
Do we have a mic that will work? Do you have
Give me 1 second. I'll try to find another mic.
Okay, that'd be fantastic.
Hold on.
Thanks, attendees, for waiting out while he tries to find a better audio solution for us. I would sing as your hold music, but you wouldn't like that very much.
Sounds good.
So Constantine, in your GoToWebinar little toolbox, you might need to go to the audio on the GoToWebinar and change your options for the mic and the speakers. Not that one. It should be right in your GoToWebinar. It's a little toolbar that sits on the right side of the GoToWebinar screen. You should have another toolbar that sits right in the GoToWebinar screen itself. You should have a panel that's probably not displayed on the screen, but it looks like it's where the dashboard and the attendees and the chat window comes up for the GoToWebinar. And within that little toolbar, there's an audio that you can expand. Oh, I think I hear something.
Can you hear me?
I do.
What do you know?
That's fantastic.
Hold on. Hold on. Switch to the internal again.
To your internal or verse to the headphones? So it looks like the GoToWebinar settings are not set up to what you're using. Which should exist in a So if you go to the GoToWebinar screen, which would be the how you joined in, the little blue flower at the bottom, go to the little blue flower at the bottom in your toolbar at the bottom there. Next to your PowerPoint slide, the flower at the bottom, the blue one. Go to your blue flower. You need to expand the audio and set it directly within the GoToWebinar tool that opens up with the GoToWebinar. Okay, now I hear you.
Yeah, it's not working. I'm not sure what that's.
Are you able to see the GoToWebinars toolbar that has the audio dashboard, polls, questions, handouts, chat screen? Do you know the toolbar that I'm talking about? Okay, sorry folks about this. We'll see if we can still get that audio. If we're not successful with our audio, we might try to reschedule this. We'll see what we can do here.
Okay, can you hear me now?
Yes.
Okay, so I'm cheating. I'm using my old laptop for a microphone and a new one for a presentation.
That's fantastic. It sounds great. Thank you. Go for it.
All right.
Okay.
Sorry about that, everyone. How do I go back? I need to go back from current slide. All right. Woohoo! All that drama just to get the microphone to work. All right, so we were talking about surrogate keys before, And as I said, the issue that we want to avoid is that creating surrogate keys of surrogate keys of surrogate keys. If you already have an existing, so if you said if you already have an existing, oh my God, I need to turn off my sound. Okay, much better. So if you already have existing surrogate keys, try to use them. The other thing that we wanted to mention is parallel thread adjustments. The OLAP engine will launch so many threads to your database engine to pull the data across. And look, by default, it's 10. That's the default number of threads that will launch. And sometimes you actually might want to adjust them either up or down depending on the hardware platform that you're actually running on. The really big one is the implicit conversion ones. Now, the implicit conversions actually come in two shapes, and some are not horrible, but some are going to be actually really, really bad. So if you can avoid it, try to avoid implicit conversion. I actually have an example of using implicit conversions, good and bad one, so we'll actually be able to show you that. I need to figure out how to turn
my speakers off.
Leslie, can you mute my? I'm actually logged in twice. Thank you. Okay, much better. All right, so the other one is physical and logical model alignment. And by default, a lot of times you actually will do physical and logical model alignment out of the gate. There are some exceptions to the rule, and again, I'm going to show you an example where it actually ended up like the physical model was not aligned to your logical model of the cube. And as the data size grew, the processing time basically became exponential. It's not even like one-to-one thing. I also wanted to mention that within the new 2014 and up SQL Server, you can leverage hackathon in-memory objects to also help yourself with the performance issues that you might, or increase your performance. And the last one is kind of like a catch-22, so it's very clever to do so. Like say, minimize extensive calculations as part of your cube build-in processing. Which is a great thing to say. Sometimes you can avoid it, sometimes you can't. If you go to SSI like SSIS performance tuning class, I'm sure they'll tell you to do the same thing. Wow, this is so unfortunate. And this sound thing is really not going well with me right now. And so if you go over the SSIS performance tuning, they'll tell you to actually not do any kind of implicit conversions or calculation as part of the SSIS and do it as part of the engine. So it's kind of like rolls downhill. And honestly, probably the database engine is the best suitable place to actually do the conversions for or deriving columns or building calculated fields, just because generally that has a lot of resources allocated to it, and the engine can handle it the best. All right, so I'm going to show you an example of a misaligned model. So this is actually an example of a DSV that's pulled from one of our clients. So you can see it, and it's just a fragment of a DSV. So that's a whole bunch of tables that are actually brought in and views that are brought in into the cube for the source objects. And this is exactly the same fragment that is used for the objects that we saw in DSV. And as you can see, there's a lot less of them. And again, that's just a fragment of that. So what actually ends up happening when you do that? When you do like a named queries to define your fact tables or your dimensions. And what happens is this. So this is a definition of a named query from that DSV that we saw, the pictures. And what you'll start seeing is this is kind of how their fact is defined. So here we're doing some Windows functions. So we're already kind of doing inline selects to get aggregated data, which is not really that bad. Then we're doing it from a fact table. Then we're doing a left join with a derived subselect. That's also doing some aggregations on top of that. That's actually based on another subselect. That's also aggregated. And then there's more, and it just continues and continues and continues to go. So that's actually a production cube fact definition from one of our clients. And there's actually a very good reason why they did this. However, as their data set grew and they got millions and millions of records, their processing time just tanked. And they actually had to jump from a whole bunch of pools and came up with workarounds to even be able to build and process their cubes. So they're actually processing 24/7, and they have a staging server where it's being processed and loaded. And then they actually move it, detach it, and reattach it nightly to their production server. So it's very unfortunate. But if you don't, like, they actually had to stand up a whole bunch of, an entire secondary environment to actually get their processing to work correctly. All right. Any questions about logical model misalignment? No. Leslie? No? Good. All right. All right. So now we're going to talk a little bit about compression, enterprise features that we can use to actually streamline our performance. So, and the three things that we actually want to talk about is compression settings, partitioning, and that comes actually in two ways. So there's a logical model partitioning, which is actually your cube partitioning, and physical model partitioning, which is the partitioning of your data warehouse to align it to your cube partitioning. And we're also going to talk about process add functionality. So I'm going to cover the compression things, and then once we get to the demo, actually I also want to show you some implicit conversion things that we're actually going to get into. So the compression considerations, like if you are running enterprise and you have a data warehousing solution, generally you should always use compression. If you're not using it now, you definitely should. There's two types of compression. There's page and row. And a lot of times in data warehousing, you'll end up using with page because it will give you the best read performance. However, if your data warehouse is somewhat transactional, where you actually transactionally load data into your tables, and it's not like a batch process, you might actually want to consider using row, because row is a lot more write-friendly than page. But if you end up going with page, and you should see the increase in performance of, at least to 70%, at least on a data pool itself. I mean, 70% has actually been a little not optimistic, but conservative. You should probably see it like at least 100%, like on how fast it pulls the data, given all the same factors. All right. So I'm going to show you. So we're going to be working with AdventureWorks here, with AdventureWorks database, which I should have probably mentioned for you guys. So it's AdventureWorks DW 2012, and this is kind of like the solution for it. So what we're looking here is the AdventureWorks data cube, and you can see that it actually aligns to the DSV. So this one is aligned one-to-one. So the logical and physical partition models are aligned. In this particular case, most of the things we're going to be actually working with is in our sales measure group or a fact table. And if you look at the fact table, This one's already actually partitioned because this is a solution that comes from Microsoft, so you can actually just download it. And what I'm going to do is I'm going to pull one of the partition definitions. So this is what OLAP engine is actually going to execute whenever you actually try to process a cube. So it's going to process, whenever it gets to process the measure group, it's going to run this query to get the partition information for that partition. And as you can see, I actually pulled that out. So this is exactly the same query that I saw or we see in here. So if I run this on my AdventureWorks, what you will see is right away, this is not properly aligned, indexing-wise or performance-wise. So I'm already getting the missing index recommendation from my plan, and I'm doing an entire table scan, but I just want a part of the table. The other interesting thing of note is the order date key is a surrogate key, which is what we want. But however, look what they're actually passing in as the variable. So they're actually passing in a string, which will result in the implicit conversion. It will actually convert this number, or this string, to a number in order to do a match. Now this is not a bad implicit conversion. And it's also a reason actually I really love Microsoft and their AdventureWorks, because they've done enough things to it that are just not quite aligned that you can actually show all of those things. Now you won't be able to see it on a plan. It actually won't show it that it's actually converting it, but it is. Now the other thing that it will do is it tells me that I need a missing index, and the missing index I actually pulled out for you in case we actually wanted to say, okay, I'm going to run a missing index information, which is, by the way, we should never do. We should never trust Optimizer implicitly to actually tell it to recommend us what it wants to do, because you can end up with a ton of indexes you actually don't need. In this particular case, it's not a really good index, and the reason for that is the included columns. So if you actually look at this, it's including every column of the table because we're selecting every column of the table. So you're creating a covering index. You're going to lose a ton of space on this, and if you have a billion row fact table, that you might just run yourself out of space by creating this index. But for the sake of argument, since my laptop will work somewhat okay, I can create this. And if I run this now, you'll see that it actually is much better, given the fact that I just created a bad index. It's doing an index seek. I'm only doing 548 pages, which was before was like 1,200 pages, which is still not a lot better than what was before. So I'm actually going to drop it. So what we actually want to do here, from our perspective of actually getting the cube processing optimized, what we need to do is actually switch our clustered index to the order date key, because clustered index is how the table is actually physically stored on disk, and that's fully covering by default. So in order to do that, I have to drop some indexes. Oh, I dropped it. All right. And now when I run this again, I don't have a bad index, but I have a clustered index seek that actually covers it. So I actually have the proper indexing in place to support the partitioning of the cube and the processing of the cube from the logical model perspective. Now, if you notice something, that's actually my page count went up. So I'm actually reading a little more data because it is a clustered index. And the reason I'm reading a lot more data is because I didn't specify it as a unique clustered index. So on a back end, the database engine will actually make it unique. So we'll add something that's called a unifier, and then it slightly blows up the size of the index. So that's the reason for the page discrepancy here. So now we're going to actually do a bad example of bad conversions. So I'm going to do some things here to drop tables and alter tables. So if you notice what I did, I actually flipped it around. So now I'm passing in a number, and I changed my order date key to become a string. And I know, like, a lot of people will be like, well, why would you do that? But we've actually seen that happen. We actually have seen where the number is passed in and the value that's actually, or the key that it's actually been looked up as a string. So what you'll end up with here is something that's very peculiar. So now when we went back to the actual scan count of 1300, and my execution plan now says that I have an exclamation point in here. Now that will only show up in 2012 or above, so they're making continuous strides to help us troubleshoot those issues. And the reason that's happening is, and you can actually see that by clicking on properties of this. Come on, and go to warnings. And what it will tell you is saying, look, the conversion will affect the targetability of the query. So and as soon as you see that, you know something is wrong. So now why is it doing that? It kind of goes back to the original statement. The computers like to play with numbers. So it saw that it passed in a number. And so it's numeric. So it's actually going to convert the column to a number as opposed to the parameter to a string. And whenever it does that, it can't use an index seek operation because it doesn't know what to seek for until it does the conversion. And that's why you end up with a wonderful exclamation point and a clustered index scan. So it means you're scanning the entire table to get a subset of a table to your cube. Now, whenever you partition your cube, you at the end result, you still need the entire table. You just want to do it in sections so you can actually pull it better. But in reality, what will happen is you'll actually scan a table. If you have 5 partitions, you'll scan it 5 times, entire table all the time. So this is actually going to be like a performance degradation for you guys instead of a performance increase. All right, so I'm going to do this all. So really avoid implicit conversions. All right, now we're actually going to move to compression. So you guys remember the original, here's the original query that we were running. And this is my page count, which is really what we need. The plan will still be seek. So in order to actually use compression, all you have to do is rebuild your indexes on the table itself as a clustered index or any non-clustered indexes that you actually have, and specify with data compression equals page. And whenever you do that, they actually will compress. Whenever you do it on a clustered index, it'll compress the table. If you do it on non-clustered indexes, it'll compress non-clustered indexes itself. All right, so I just compressed it. So if you notice that, if I rerun this, what will happen now is that my scan count or my page count went to 166. From 600 pages to 166. Now this is a very small result set. I mean, I might have like 100,000 rows total here in the table. And I got almost 4 times less data being read in to be pulled into OLAP. That's a pretty substantial increase if you can use page compression. Actually, I'm reading 32,000 records here. Why am I even saying 100? All right, so now the same thing we're going to do is we're going to compress it with row. And I said row is a lot write-friendly than page. And if I rerun this, you'll notice that even though I still get a gain, but it's not going to be as much of a gain. So now, I mean, I get about half the pages from the original table and twice as much as opposed to doing page compression. So it's somewhere in between. So you're kind of sacrificing a little bit on read, but you're improving your write performance. Any question about compression? All right, cool. So now we're going to talk about partitioning and actually logical model partitioning. Now that's actually pretty easy to do because you can do it in a multitude of ways. You can partition it from your Visual Studio solution. Obviously, you'll have to redeploy your cube afterwards. You can partition it straight from OLAP, either through the GUI on OLAP as an SSMS or for an XMLA query. And that just requires a reprocess. Now, as I said, like what we were looking for, and I was already demonstrating that a little bit, is like the things to watch for whenever you actually do this. You must have proper indexing structures in place to support your logical partitions. Otherwise, you're really not helping yourself that much. You can kind of go through the motions and say, oh yeah, I partitioned the cube. Our cubes, of course, they're partitioned. Who doesn't partition their cubes? But in reality, it actually doesn't do anything to streamline the performance of your processing. And if you do have to change indexes to support the partition of your cubes, make sure that you have to go through the full life cycle to make sure it doesn't negatively affect other processes as well. And I always want to say implicit conversions because there sometimes could be bad. All right, so we're going to do, where's my Visual Studio? All right, here we go. So we're actually going to do a partition definition from Visual Studio, and then I'm going to show you how to do the same thing in OLAP. So here I said I just went to partitions, and so from cube structure, I said internet sales. This is my measure group that we're working on, and I'm going to go to partitions, and it's going to show me all the partitions that are currently defined and what estimated row counts for each partition is. So if I wanted to create a new partition, all I have to do is click New Partition. And before I even do that, I'm going to steal a definition of a partition. So once I click a new partition, I have to specify which table I'm actually going to add a partition to. And this is internet sales fact. And now I have to do is specify a query to run, so to restrict rows. Now it's actually going to automatically pull in every column that the fact table is used and how they're defined from which fact table, and it's going to leave you the empty where clause. Now since we're all somewhat lazy, and I already copied the partition definition of the old one. So this was a partition for 2008. Now I can just switch it to be 2009. And now I have a partition for 2009 data because I'm restricting it for anything for 2009. Now, which server instance is it going to go to? This one, I have to call it. So, internet sales 2009. And the aggregation design thing is kind of generally, you could probably generally want to use if you already have partitions, use the aggregation design as long as your kind of partitions are on the same size level, like row-wise. You can actually reuse the aggregations that were designed previously, or you can actually choose to design aggregations later. Or if you do design aggregations now, that actually might take longer and put some load on your server to actually help streamline the aggregations. Now and you can actually, whenever you choose to design aggregations, you can pick and choose how much of aggregations you actually want to do ahead of the time. So usually it's kind of like a balance thing. So in this particular case, I'm actually going to copy aggregations that are already existing from Internet Sales 2005 partition. And boom, I have a partition. Now, this is just in my Visual Studio. I have to redeploy the cube and reprocess it to actually repopulate the data to it. Now, you can do the same thing right in OLAP. So this is the deployed model of the cube that we had before. And if I go to the internet sales, and I already have my partitions, and you can see that even though I created it, there's nothing here. I can just do a new partition. And guess what? It's the same wizard that comes up. So it's exactly the same wizard you had in the Visual Studio, how you define a partition. The other way is to run an XMLA query, which is what we see here. And here's my partition definition, and it's for 2009. And I can just run that. And if I run that and refresh, and go to partitions, now I have my 2009 partition. So that's generally how you partition a cube from a logical model perspective. Any questions about that? And I'm rushing a little bit since we had so many, I had so many issues with microphones at the beginning. All right, so partitioning with physical alignment. Generally, even if you created a proper indexing in place on your data warehouse to support the partitioning of your cubes, it's still better off to actually physically align partitioning on both the data warehousing and the cubes to actually coexist at the same time. Just because index seeks, like we see in the plans, I mean, that's just an estimation where to start. It provides a better starting point. Whenever you actually partition the tables underneath, you can use a partition elimination, or the engine will use partition elimination, which is an exact, like I don't need any of these partitions, I'm not even going to look there. It also removes the need for additional indexes to support logical partitioning, or in some cases it removes it. And if the existing indexes were modified, it removes the risk of partition affecting other critical processes. You can also take advantage of multiple I/O location or storage locations. So if you have a SAN, or if you have like a whole bunch of local disks with different RAID groups, or you have multiple SANs connected to it, or you have a caching card for some fast stuff and some slower disks for some slow stuff, you can actually separate your tables between all those disks to actually improve your performance. All right, so I'm actually going to get right into partitioning. So in order to do partitioning, you have to obviously make some changes. So the partitioning, it could be done in a whole bunch of different ways, and there's a whole ton of information online on how to do partitioning on a database and what's the best way, and can you do it this way or can you do it this way. So I'm going to just go from one of the ways to set it up just to make it easier for everyone, and I'm going to use an approach that's going to take into account that at some point we actually want to do physical I/O separation. So I'm going to create multiple file groups that could technically be placed on different drives. So I'm going to add 5 file groups to my AdventureWorks database after I connect. And then I'm going to add a file to each of those file groups. And now this is where you actually guarantee where the partition of this table is going to be stored, which disk. So that's actually the guaranteed method of partitioning. Now that I created my file groups and files, I'm ready to actually start partitioning my tables. So the first thing you have to do is actually create a partition function, which defines the boundaries of how my table is going to be broken up. So we're partitioning on order date. So that's a surrogate key, that's an int. So, and here's my partition function definition. Now, generally, there's 2 ways you could do this. You can do it for range right or range left. A lot of things that's important with how the split functionality and merge functionality is going to work, or where the boundaries included within a partition. If you ever consider doing a sliding window partitioning or something like that, I would recommend using range right instead of range left. So I'm going to just go with range right. Now, I've done that last time I did this, so I created a partition function on master. All right, now that I have the boundaries for my partitioning, I have to map those partitions to the actual file groups and how they're going to be used. So this is where you create a partition scheme. And once you create a partition scheme, you can, again, there's a whole bunch of options. I can actually tell it to reuse the same file group over time. I can say part 1, part 1, part 1, part 1, part 1. I can round robin this. I can say all to part 1. But in this particular case, since I'm only creating 5 partitions and I have 5 file groups, I can actually specifically say all 5 file groups. That works. So now I'm actually ready to partition the table. So in this particular case, in order to partition the table, all I have to do is actually rebuild the clustered index, which is how the table is stored, and specify the partition scheme I created and which column is actually going to facilitate the boundary definition. Now, one more requirement for this is that the partition column itself has to be part of the clustered index. Now, it doesn't matter where it is, it just has to be a part of it. So in this particular case, since we're using partition elimination, and I don't care for it to be a seek predicate, I just put it as a last column. So my seeks are still done on sales order number, which is what the original index originally was, and sales order number is a secondary. And I'm still using my data compression thing, which is really good. So once I do this, you can see that now, if I look at my tables, it's actually showing as partition and properties, and there's actually another way to look at it, which is the partition distribution example. So I'm actually, this is going to pull information that's everything that's partitioned on partition function, partition schema order date. So if I run this, it'll tell me how my table, which table is partitioned, which schema, which function, which partition number, and how many rows are in each partition, and which file group they map to. So if you actually notice this, those numbers look very, very similar to what we saw in the cube in here. So the estimates that the OLAP did is actually very, very close to be true according to the actual physical data in the table. So now that I've run exactly the same query, what you'll notice is that I'm actually not doing a seek anymore. I'm actually doing a clustered index scan. But from the pages perspective, when we're doing a clustered indexing and not using partition, we're doing 166 pages read in. Now that it's partitioned, we're only doing 160 pages. Again, on a smaller scale, that really doesn't seem like that big of a deal. However, whenever you get to billions or multi-million row partitions and tables, that could add up pretty quickly in time. All right. Any questions?
None yet.
All right, cool. All right, so we're going to talk really quickly on incremental processing because, again, I'm actually running out of time. So, the other thing is, if this is all enterprise level features, so the compression is only available on enterprise, and actually the database level partitioning is available in enterprise only. But if you are running on standard, there is a workaround that you can actually use for partitioning in standard, and it's called partition updatable views. So if you're still on standard and you want to take an advantage of some kind of partitioning, you can actually use partition views to accomplish kind of the same result. Unfortunately, that would be a lot more management on part of the DBAs to actually keep it up to date all the time. But that's also an option. So let's say you actually did all of this and you're still not getting to within the window that you need. So what can you do? You can actually use process add functionality. That will only add new data to your cube that's actually been processed through your batch processing on a daily cycle. It can only be done through an XML query, and you have to be very careful when you actually use this because you have to really know your data and make sure it actually works for your environment. You could get into trouble. And even if you do use a process add functionality, you should still at some point have a full reprocess of the cube run throughout like some kind of period of time, whatever that may be, weekly, monthly, whatever the business dictates. I actually just was talking to the other week, was in Tampa SQL Saturday, and one of the person who was visiting my session, he's like, that's exactly the problem. And we had like 2 weeks ticket open with Microsoft, and then they told us just do a full reprocess once in a while. And that was the solution to their problem. They actually had discrepancies in their data. All right, so I'm actually going to show you an example of process add functionality. I will not be able to run it, unfortunately, just because this is, again, it's actually from one of our clients. And what you can see here is that the type of processing is process add, and what they've done is, or what we've done, is they actually filter their, this is a dimension. They filter their dimension based on what's actually been loaded in that day. And the query for that is right here. Try to make it. So they have a staging, shared configuration staging table for their facts. So this is actually kind of keeps information what they've loaded before and what the last surrogate key was actually was processed. So whenever they do process add, they only select the rows that are new from the previous process cycle. And that's how they filter their process add functionality for the dimension. Okay, and kind of like just to wrap this up really quickly, so make sure you configure your topology to best suits your business needs. If you can use the business best practices, by all means do so. They will only help. They will never really hurt you. And make sure you actually look that your models are aligned, because that's the biggest issue we've seen. As soon as we see a misaligned models, usually at some point the performance is going south. So again, sorry again for the microphone issues that I had earlier at the beginning of the session, and I hope this was useful to you.
Well, I'm really glad we got that fixed.
Yeah, it took a lot of panicking on my part.
Okay, so I do have a couple questions for you.
Sure.
Can you turn off all implicit conversions?
What do you mean then turn off?
Well, so he has nvarchar with numbers kills me when a decimal is added. Can database, not my design. Is there anything you can do in the governor resource? I was wondering.
You can do it in a governor resource, but that's not, you're just limiting how much actually resources that any given query is taken.
Yeah.
So you want, or a pool is allocated resources to actually process. So if the idea is to process it as fast as possible, you want to give it as many resources as you can. If that's something like that is happening, you might want to restrict it so other things can go through, but you kind of slowing down your process for using a resource governor.
So maybe it's better code review?
Better code review, yeah. So the first implicit conversion that I showed you is not really horrible. It's just a slight CPU overhead. Most of the time, our slowdowns actually occur on the disk subsystem. So as long as it doesn't affect your ability to bring in data efficiently, CPU usually we have a little bit to spare. It's the second implicit conversion that you want to really avoid when it's actually become a non-sargable query.
Okay. Another question for you. Maximum of 10 threads was mentioned earlier in the presentation. Can you expand on this a bit? Is this per DSV?
It's per cube. It's not maximum. It's actually the default. Did I say maximum? It could be higher. You can actually tell it to go higher. By default, it will launch 10 threads to process, to pull data out of your data warehouse.
Okay.
So you can actually tweak it based on how many cores you have, because you might actually starve a couple of threads that are just going to be sitting there and waiting. So if you only have 8 processors, you might pulling 10 threads out is actually not going to give you any benefit, or going to like 24 or anything like that. You might want to just bump it down to 8. Now, if you have 40, you might want to go higher than 10 to like 20. It just depends what your system can handle.
Okay, fantastic. Also, quick question on, do you have any recommended reading or sites or blogs that you would recommend on this?
Oof. I don't have I'm using 2 laptops and I don't have any of that information on top of my head. I will have to, how about, if they want to send me an email, I will be more than happy to reply and give them a whole bunch of forms that I usually hit up for, like data warehousing if I have a question or anything like that.
Okay, fantastic. So we will have this recording on the website within the next week, and a copy of the slides also. So, Con, thank you so much for joining us today. I appreciate it.
Yes, again, sorry for the microphone mishap at the beginning.
That's okay. It happens. Hey, have a good day, everyone. Thanks for joining us. Bye.
All right, thank you.